In probability chapter, we have learned what is Bernoulli theorem and where we can use the Bernoulli theorem to calculate or solve the problem of probability. In today's video also we will having some more question related to the Bernoulli theorem. The first question is this: one bag contains 8 red ball, 3 white ball and 9 blue ball is over there. 3 balls taken from this bag. We are to calculate the probability of getting all red, all white, 2 red, 1 blue, at least 1 white, 1 red, 1 blue, 1 white, and in this order: first red, second white, third blue. So we are having 6 questions. The very first I should repeat the question. One bag contains 9 red ball, 8 red ball, 3 white ball and 9 blue ball. So total ball is 20 and we are to bring 3 balls with this box. Now we are to calculate that all red, first one, all red, for getting 20 balls. So all red, so red is 8, so there will be 8C3 divided by 20C3. The total number of event is 20. 20C3 is over there for getting, and getting red, that is 8C3. Okay. What we are having, the total number of balls is 20 and we are to collect 3 balls, so the total events is 20C3 and we are to calculate the probability of all red. So there will be 8C3 divided by 20C3, so that will be 8, 7, 6 divided 1, 2, 3 divided 20, 19, 18 divided 1, 2 and 3. So will be 8 multiply 7 multiply 6, 20 multiply 19 multiply 18. 6 3 ja 18. Okay. 2 4 ja 8, 2 5 ja 20. Okay. So there will be 14 divided by 15 multiply 19. 285. So first will be 14 divided by, the answer of first is 14 divided by 285. Second question is all white. So all white is 3. So 3C3 divided 20C3. So 1 upon 20 multiply 90 multiply 18 multiply 1 multiply 2 multiply 3. 3 6 ja 19. Sorry. 6 3 ja 18, okay, and 10. So 190 multiply 6. So this will be 1 upon 1140. Second answer will be 1 divided by 1140. So the 2 question we have done. The very first, all red required. So all red required. So 20C3 is the total and number of favorable event is 8C3. Already we have. Now second question, for all white is required, so 20C3 and all white 3C3. So the value of 3C3 is 1. So 1 divided by 20C3 divided this. So we have done 2 questions. Now 2 red and 1 blue. Third question is asking, question number 3 is 2 red and 1 blue. 2 red, 1 blue. So total number of event 20C3. For getting 2 red, 8C2. For getting 1 blue, that 9C1. So 8 multiply 7, 1 multiply 2, 9 divided by 1, 20, 19, 18 divided 1 multiply 2 multiply 3. 3 6 ja 18. This is 10 times, this is 4 times. So 4 multiply 7 multiply 9 divided 10 multiply 19 multiply 6. 6 2 ja 3 2 ja 6, 3 3 ja 9. 2 4 ja 2 2 ja 4 and 5. Okay, so there will be 7 multiply 3 upon 5 multiply 19. 21 upon 85. So answer will be 21 upon 85. So we have done 1, 2, 3 question. At least one white. Now at least one white. For at least one white we will having 0 white. Firstly we will calculate 0 white. At least one white. So 0 white. So 17C3 upon 20C3, that is 0 white. So that will be 17 multiply 16 multiply 15 multiply 1 multiply 2 multiply 3 divided 20 multiply 19 multiply 18 divided 1 multiply 2 multiply 3. 5 3 and 4. 4 4 ja 16 and 2 and this is 9. Okay. So here 17 multiply 2 is over there. Here 19 multiply 9 is over there. At least one white. So 1 minus probability of 0 white. So 1 minus 34 upon 19 multiply 9. 171. 171 minus 34 upon 171. 137. 17C 17 16 15 divided by 20 19 and 9. Okay, so some difference may be over there. Here 17 16 15 20 19 18. Okay, so againly we are having this 17 16 15. One more times I am having 17 multiply 16 multiply 15 multiply 20 multiply 19 multiply 18. 5 3 ja 15, 5 4 ja 20, 4 4 ja 16. Okay, 3 6 ja 18, 2 here, 3 here. So there is 19 multiply 3 only. Okay, this was the difference. So 1 minus 34 upon 57. 57 minus 34, that is 23 upon 57. Answer will be. So at least 0 white. Firstly we will get 0 white and 1 minus probability of 0, that is at least 1 white is over there. Now 1 1 each. 1 1 each we are to calculate. So we are having 8C1 multiply 3C1 multiply 9C1 divided by 20C3. So 8 divided 1, 3 divided 1, 9 divided 1. 20 multiply 19 multiply 18 divided 1 multiply 2 multiply 3. 3 6 ja 18 and this is 10 times. 3 2 ja 6. This is 4 times, this is 2 times, this is 5 times. So that is 18 divided by 85. 19 5 ja 95. So there will be 18 divided by 95. Now 1 1 each is over there. So 1 1 each, 1 red, 1 white and 1 blue. Now the order is also that first ball will red. So first ball, probability of first ball red is 88 upon 20. For getting second ball is white. So second ball is white, 3 upon 19. And third ball is blue. So that is 9 upon 18. 9 to ja 18. That is blue, that is white, and that is red. 9 to ja 18. 4 ja 8. 5. So 3 upon 80, 95. So the probability of is 3 upon 95 is over there. So in any type the question is over there. If you will go by and by, what the question is asking, you go with the question, you can certainly solve the question is over there. One more question related to second number question. From a pack of well shuffled 52 cards, 2 cards drawn at a random, what is the probability there will be a king and another one will queen? From a pack of well shuffled 52 cards, 2 cards drawn at a random, what is the probability that the one card will be queen and second one will be king? For getting 2 cards from 52 cards, that is 52C2, for getting 1 king and 1 queen, 4C1 and 4C1. Because in playing cards there are 4 king, there are 4 queen is over there, so 4C1 and 4C1 divided by 52. So 4 divided 1, 4 divided 1 divided by 52 multiply 51 divided by 1 multiply 2, that is 26, 13 and 2. So that is 8 upon 13 multiply by 11. Multiply 11, not 51. 663. So the answer will be 8 divided by 663. The answer will be 8 divided by 663. But it's easy. It's very easy. From a pack of 52 cards, okay. From a pack of 52 cards, 2 cards drawn. From a pack of 52 cards, 2 cards taken and thrown, and from remaining, get the probability of getting a king. Againly, I repeat the question. 2 cards are randomly drawn from a pack of 52 cards and throw away. What is the probability of drawing a king in a single draw from remaining 50 cards? It means from 52 cards, 2 cards taken and without seeing they thrown. Now from remaining 50 cards, 1 card is taken. What is the probability that that card will be king? So there may be 3 probability. We have taken 2 cards. They may be all 2 may be king. There may be 1 king, 1 other card, and there may be all other card is over there. So for getting a king from the remaining have some difficulties over there. First probability this, that thrown 2 is king. Second is 1 king, 1 other. Third probability is that 2 other. If 2 king is over there, then remaining king is 2. If 1 king is remaining 3, and this is remaining 4. If thrown card are both are 2 king, then in remaining 2 king is over there. If thrown card having 1 king and 1 other cards, now in playing cards among 50 there are 3 king. If both 2 are other cards, then remaining is 4 king is over there. So we have to get the probability seeing this. So the very first we are having the probability that 2 king gone. So there will be 4c2 upon 52c2. Okay, then 2 upon 50 getting king. What we will having? The very first we were having 4c2 multiply divided by 50c2 and 2 upon 50. If one is king and one is other, so getting one is king 4c1, getting other 48c1 divided by 50c2, and in remaining 3 is over there among 50. 2 other is over there, then 48c2 upon 52c2 multiply 4 upon 50. There are 3 conditions is over there. This question I have some tricky. Okay, go to this. From a pack of 52 cards, 2 cards taken and thrown. From remaining 50 cards, we are to get the probability of getting a king. Okay. So the first probability is that the thrown card, both 2 cards is king. Then our in 50 remaining card there is 2 king. The second probability that there may be 1 king and 1 other cards. So 1 king gone, so 3 king is available. And if 2 other card is gone, now 4 king is available. So in the very first condition, 2 king gone, so for getting 2c2 divided by 52, so 50c2, remaining 50 card is over there and 2 is king, so we can write here this also 2c1 upon 50c1, no problem. Okay, 1 card and 1 other, so for getting 1 king 4c1, other 48c1 divided by 50c2, and remaining 3 is over there, so we can having 3c1 upon 50c1, no problem at all. And 2 other is over there, so getting 2 other is 48c2 divided by 52c2, and this other is 40 divided by 50. So we'll solve this. 4 multiply 3 upon 52 multiply 51, 2 multiply 50, plus 4 multiply 48 divided by 52 multiply 51 divided 1 multiply 2, so that will be 1 multiply 2, so that will be 26. 3 upon 50 plus 48 multiply 47 multiply 52 multiply 51 multiply 4 upon 50. We have to solve this. Here 1 2 cancel. In this only 1 was over there, so that's why we have taken this. Okay. So this is 26 and this is 26. So in upper part 26 multiplied 51 multiply 50. 26 51 50. 26 51 50. 26 51 50. So here 12 is over there. 48 multiplied by 4. 576. 48 multiply 47. Multiply 2. 4 5 1 2. Five 1 0 divided by 6 6 3 0 0 00, so that will be 51 upon 6 6 3. So if this type of the question is over there, then we have to keep what the question is asking, then we have to solve the question. Otherwise it will make a problem for you. So this type of the question, it may be no problem at all if in this type of the question is over there. then also you can solve the question without any hesitation. One man can solve 70% of the question. A can solve the 70% question. One question related to this. A can solve 90% question and B can solve 70% question. What is the probability that if a question given to A and B, at least one of them will solve? The question is this: A can solve the 90% question of a book, B can solve the 70% question of a book. It means out of 10, 9 question A can solve, 1 question he cannot solve. Out of 7 question he can solve and 3 question he can't solve. Now we have to calculate the probability that at least one of them will solve the question. So at least one of them solve बराबर 1 minus probability of 1 and 1 minus probability of 2. So first one cannot solve, that is 1 upon 10. Second cannot solve, that is 3 upon 9. So at least one, that is 3 upon 90, 3 upon 10. So 100 minus 3 upon 100, that is 97 upon 100. It means there is 97% chance that question will solve. The question was this, that A can solve the 90% question of a book and B can solve the 70% question of the book. So the probability out of 10, 9 question A can solve and out of 10, 1 question he can't solve. Out of 10, 7 question B can solve and 3 question he can't solve. A question given to A and B, what is the probability that at least one of them will solve the question? So for getting the probability of at least one of them, so that is 1 minus probability of A cannot solve and B cannot solve. So not solving by A, that is 1 by 10. Not solving by B, that is 3 upon 10. So the probability of not solving is 3 upon 100. So the probability of solving is 97 upon 100, and we are having there is a 97% chance that the question can solve. So I think with the help of this video, you may be learn how to use Bernoulli theorem for calculating probability is over there. We are having some more question related to this in our next video. Thank you for